depending on whatever is the select input. So it is this multiplexer will select that input. So either it will be select from the flip flops output or it will be selecting cascade chain output. Okay. So ज्यावेळेस इथे कॉम्बिनेटरियल सर्किट असेल त्यावेळेस हे लुकअप टेबलचं जे काही आउटपुट आहे ते कॅरी चेन आणि कॅस्केड चेन थ्रू इथे या मल्टिप्लेक्सरला ॲज अ इनपुट मिळणार आहे आणि देन it will be given to the row as well as column interconnects. Okay, and at the same time if required it will be given as a input to the logic array block local interconnects. Okay, so it will be given. Okay, so now at that time only these dedicated inputs that will be the inputs to this lookup table. Okay, so this combinatorial logic that will not require clock signals as well as reset signal, so that will not be used here. So this block will also be not used in this combinatorial logic design. Okay, but whenever we are going for the sequential logic design, then these data inputs that will be given to the this flip flop through the multiplexer as well as OR gate, and then here this uh, logic that is a for which is used for the clear or preset logic, that block will be also used here. Okay, so that will be these signals that will be used for clearing of the or resetting of the flip flop, and then uh, it will use also a clock signals, that is a logic array block clock signals 1 and 2, as we know that there are two clock signals, so that will be used. Okay, now depending on the clock select here, the which clock that has to be used, that will be decided through this multiplexer. Okay, and then here whatever is the output of this flip flop, that will be now connected to the row as well as column interconnects through this multiplexer. That means this multiplexer will select that this now, as it is a sequential logic design, so whatever is the output of this flip flop, that will be connected to the interconnect. Okay, as well as to the logic array block. Okay, so here this is the logic element in a Altera Flex 10K. Okay, so this is about the architecture of this Altera 10 Flex. Okay, so we have discussed about logic control signals, then this logic element, then we have discussed earlier what is the structure of or the block diagram of this Flex 10K family. So that we have discussed. So in your examination there will be question regarding explain architecture of Flex 10K family. So you need to discuss about these block diagram of this Altera Flex 10K, and then you need to discuss about these elements which are used in a that family. Okay, so that is about the Altera 10 Flex Altera Flex 10K FPGA. Okay, so now let us discuss about FPGA advantages. Okay, so as FPGA, that means field programmable gate array. So this has the fast digital design and there is no wait to obtaining a target chip. So we can directly get whenever we do a programming, so we can get a target chip that is ready with us. So that is a fast digital design. Now when you are designing with a CPLD, so it may require certain more time as compared to FPGA. Okay, the design can be implemented on the FPGA and tested at once. So whatever is the design that you want to do, that can be directly implemented on FPGA and then it is tested. Okay, so if there is any correction, that you can do it again. So as FPGA is programmable so many times, so you can do it easily. Then FPGAs are good prototypes. After final design, the product is so small size. So that is one of the advantage of FPGA, that whenever you are going for the final product, it is a very small size, and that is why your overall product that will be of a compact size. The designer can be used the same FPGA more than design. Okay, so it the same FPGA can be used for more designs, and that is again one more advantage of this FPGA. Now let us discuss about FPGA applications. Okay? So for if you want to design any new CPU or DSP cores, then that there FPGA can be used. Then computer architecture experiments. So there also FPGA is used. Then build up test equipments for clock as well as pulses. Okay. So if you want any lab test equipment that need to be manufactured, so in that FPGA can be used, because here you can program that FPGA chip. So many times you can do it according to your specifications, and that is why it is easy to build any equipment. Then in a telecommunication protocol analyzer, FPGA is used. Then sigma delta DAC, there also FPGA is used. Then digital modulator or in a modem, etc. FPGA is used, and in a neural network also FPGA is used. So whenever you are going for any application, image processing application also, so where you are doing certain processing on your image, and then you want to show it. Okay, so that there also FPGA chip is used. Okay, so that are so many, there are applications regarding this FPGA. So that is regarding the FPGA which we are using in a VLSI design. Okay, so this was one of the part of your 6th unit, that is the architecture of commercial devices. Okay, now so that means here till now we have discussed which ICs, commercial ICs, कुठले कुठले ICs आपण चेक केले. Yes. Altera Flex 10K. Okay. So right now also we discussed that. So you should be able to answer that. Okay. And then Max 7000. Then another, which IC we have discussed earlier? Xilinx XC9500. Okay. So till now we have discussed about what is CPLD architecture, then Xilinx XC9500, Altera Max 7000, and Altera Flex 10K. Okay. So Max 7000, that is a CPLD, while Flex 10K, that is a FPGA manufactured by Altera itself. So the manufacturing company Altera, but Max 7000, that's CPLD that we have discussed, and then Flex 10K, that is the FPGA that we have discussed. Okay. So the remaining point, that is ASIC and system on chip architecture. Okay. So from this unit, we need to now discuss about this. Okay. So now here for these, we are just going to introduce with what is mean by ASIC and what are the different types of ASICs, and then what is mean by system on chip. Okay, so that we are going to discuss here. We are not going to, as it is an application specific, so we are not going to discuss about any IC here. Okay, so just depending on whatever is your design, how we can go for these type of systems that we are going to see. Okay, so now I will share my another PPTs with you. So now we are, as I said, now we are going to introduce ourselves with what is mean by ASIC and what is system on chip. Okay, so architecture of this that we are going to discuss. Okay, so now what is first, that is a we are going to discuss about ASIC. Okay, what is mean by ASIC? It is an abbreviation of application specific integrated circuit. Okay, so it is ASIC, that abbreviated, or it is called as a ASIC. Okay, it is an integrated circuit. That means it is an IC which is customized for particular use. So this whatever is your applications or user application, depending on that, it integrated circuit is customized. Okay, that IC is designed in such a way that it will fulfill users or customers specifications, and that is called as a ASIC. So it is a compact in size, but it is working depending on users specifications. Now, as I said, ASIC, that is an application specific integrated circuit. So it is used to perform, or it is designed to perform a specific function for specific application. Okay, that means suppose you want to design any toy. Okay, so for that, that means you must have seen certain teddy bears. Okay, so that are talking toys. Okay, so for that, whatever is IC required, that is ASIC, because it is specifically designed for that toy. Okay, so it is a application specific integrated circuit. Or if suppose you are designing any system uh, which a standard cells are not available for that, so that is also a ASIC. Okay, so as there is a different level of integrations in a ASICs also. So depending on how many transistors are present in a ASIC, it may be a small scale integration, then medium scale integration, or large scale integration, VLSI or ULSI, that is a ultra large scale integration. So that may be the level of integrations in a ASIC also. म्हणजे कुठल्याही आयसी मध्ये ज्याप्रमाणे आपण लेवल ऑफ इंटिग्रेशन असतात की जर ट्रान्झिस्टरची साईज कमी असेल तर आपण त्याला स्मॉल स्केल इंटिग्रेशन होतो म्हणतो, आणि ज्याप्रमाणे ट्रान्झिस्टरचे नंबर्स वाढत जातील त्याप्रमाणे ते मीडियम स्केल, लार्ज स्केल, व्हेरी लार्ज स्केल किंवा अल्ट्रा लार्ज स्केल इंटिग्रेशन साठी. ओके, सो वी आर कॉलिंग इट ॲज अ like that way. So the implementation technology is in ASIC, that is a TTL logic, or it may be ECL, that is a emitter coupled logic, or it may be a metal oxide silicon, that is a MOS logic. So NMOS and CMOS transistors that are used in for the implementation of ASICs. So most of nowadays, most of the implementation technology, that is a MOS transistors, because it is using a very less voltage requirement. Okay, so now let us discuss about different types of ASICs. So we can have a classification of ASICs as shown over here. Okay, so ASICs, it is mainly categorized into three types. One is the fully custom, another one that is a semi-custom and programmable. Okay, now this semi-custom ASICs that are again categorized into two types. One is the standard cell-based ASICs, or another one that is a gate array-based ASICs. Okay, now this gate array-based ASICs, these are again categorized into three types. That is a channeled ASICs, channelless ASICs, or structured gate. Okay, and then third type of ASIC, that is a programmable. So it is categorized into two types. One is the PLDs and FPGA. So whatever we have discussed till now, that is also ASIC. Okay, that means if you are using a PLDs, so that is also ASIC, because you are going to program it according to your application. Or FPGA also you are going to design it according to your application, and that is why it is also a application specific IC. So that means A fully custom ASIC. Okay, so let us discuss about that. So fully custom ASICs is one which includes some logic cells that are customized and all mask layers that are also customized. So here, when we are calling any IC that is a fully custom ASIC, then that means that there are certain logic cells that are customized or that are programmed according to the specifications. Okay, so and again, as for the manufacturing purpose, we require to have certain mask layers. Okay, so that means certain masks that need to be created so that we can manufacturing it. So that are also customized as because routing of these components on a chip that may differ, and so that is also customized, and then we call that IC as a full custom ASIC. Okay, so a microprocessor is an example of full custom IC. Designers spent many hours squeezing out most out of every last square micron of microprocessor chip space by hand. Okay, so that means whenever this microprocessor is designer need to be check where to place a certain component, then how to connect it so that there will be minimum area required on for this components or for all the cells that are present in the microprocessor. So that is a fully customized. Customizing all of the IC features in this way allows designers to include analog circuits, then optimize the memory cells or mechanical structure on the IC. For example, as I said here, any circuit that can be built using this ASICs. Fully custom ICs that are the most expensive to manufacture and design. So this is the drawback of full custom IC, that they are expensive to manufacture because the mask layers as well as this logic cells, these are customized, and that is why designer has to work a lot for designing these ICs. Okay. Then uh, the manufacturing lead time that is which is required for manufacturing of this IC. Okay, so which is not including a design time, just for the manufacturing of this IC is typically 8 weeks for a fixed full custom IC, because as said, we need to design or we need to customize the mask layer also. So the manufacturing time that is high in a fully custom IC, and these specialized full custom ICs are often intended for specific application. So we might call some of them as a full custom ASIC. So wherever you are going to design certain specialized ICs, so you can call them as a full custom ASIC. In a full custom ASIC, an engineer designs some or all of the logic skills, circuits, or layout specifically for one ASIC. This means the designer avoids using pre-tested and pre-characterized cells for all or part of that design. Okay. So we can summarize this full custom ASICs as it is the IC where a pre-tested cells are rarely used. Okay, so designer prefers to use his own design in a circuitry. Okay, so that are the ICs which are manufactured in this way, that are called as a ASIC. So this might be because existing cell libraries are not fast enough, or logic cells are not small enough, or consume too much power. So why designer goes for another his own design? Because sometimes it may require that that size of that logic cells that should be small. Okay, So this designer can place all the transistors in that design in such a way that he can minimize the space required. Also, uh, he may it may happen that whatever are the existing cell libraries that are consuming much high power, okay, so he can use certain transistors, or he can minimize the interconnects in such a way that the power consumptions that will be reduced. Now, as you know that whatever are the interconnects that are producing capacitance, and because of that capacitances, there will be certain voltage drop. Okay, and so it consumes power, more power. So that can be reduced using customized design. Um, as we, it may have possible that there may be reduction in the interconnects, and as there is also reduction in the space. Okay? So one has to use full custom design if the ASIC technology is new or so specialized that there are no existing cell libraries, or because the ASIC is so specialized that some circuit must be custom designed. Fewer and fewer full custom ICs are being designed because of the problems with these special parts of ASIC. The growing member of this family nowadays is the mixed analog or digital ASIC. Mixed analog and digital ASICs. Okay. So here, whenever a designer want to design certain new thing or certain specialized thing, so that time he is going for the ASIC design. But as it is a lengthy process, it requires more time, as well as it is customized. So very few ASICs are specially designed. Otherwise, most of the designs that are using existing cell libraries. So here a very few full custom ICs that are available. But mixed signal design, as I said that there is a in earlier session that there is a lot of scope in a mixed signal design, because uh, on a single chip there is a analog signals and digital signals that are processed. So there is a very uh, growing uh, demand for this type of design, and so this analog and digital ASICs, this is the very demanding application in a VLSI design. Okay, so there is a lot of scope for this type of ASICs design. Now, another type of ASIC, that is a semi-custom ASIC. Okay, now as ASICs, that means it is a application specific ICs. But here in a semi-custom ASICs, uh, all of the logic cells that are pre-designed and some of the mask layers are customized, that are called as a semi-custom ASICs. Okay, that means here logic cells are used which are pre-designed, but they are routed in such a way that mask layers that are customized. Okay, so this is the semi-custom type of ASICs using the pre-designed cells from a cell library. That makes the design much easier, because whatever is the design that is already available in the library, you just need to pick that cell and place it. ओके, म्हणजे ज्याप्रमाणे तुम्ही आता करता तुमचं सर्किट बिल्ड करता, त्याच्यामध्ये तुम्ही काय करता की जे ट्रान्झिस्टर अवेलेबल आहेत किंवा काही आयसीज अवेलेबल आहेत त्या तुम्ही तुमच्या ब्रेडबोर्ड वरती किंवा पीसीबी वरती माउंट करता आणि त्याचे कनेक्शन्स करता. ओके, सो आता हे करताना बरेच जण काय करत असतील की तो सेपरेट सेपरेट असे कंपोनंट्स ठेवत असतील की ज्याच्यामुळे त्याला ते दिसायला इझी जाईल सर्किट. काही जण असं करतील की ते सर्किट काय कसं दिसतं याच्यापेक्षा ते किती मिनिमम साईज मध्ये बसतं, म्हणजे तुम्हाला लागणारा पीसीबीचा साईज किती कमीत कमी आहे ते बघेल. ओके, सो डीप म्हणजेच काय आहे की तुम्ही प्रत्येक जण तो तुम्ही सर्किट जे काही बिल्ड करणार आहे ते कस्टमाइज करा. त्याचप्रमाणे इथं पण आहे की सेमी कस्टम ASICs मध्ये काय करेल, ज्या काही सेल्स आहेत त्या प्री डिझाइंड आहेत, फक्त त्या कशा प्लेस करायच्या म्हणजे त्यामुळं मास्क कसा येणार आहे तो कस्टमाइज्ड. ओके, so that type of ICs that are called as a semi-custom ASICs. Now, these semi-custom ASICs, these are again of two types. One is the standard cell-based ASICs, and another one that is a gate array-based ASIC. Okay, so let us discuss what is mean by standard cell-based ASIC. A standard cell-based ASIC that is also abbreviated as a cell-based ASIC, or it is a CBIC, which is pronounced as a CBIC. Okay, so that means it is a standard cell-based ASIC. Okay, so these uses pre-designed logic cells, that means AND gates, OR gates, or multiplexers, flip-flops. These are some of the examples of pre-designed logic cells, and which are also called as a standard cell. So these are used in a cell-based ASIC. One can apply the term CBIC to any IC that uses cells, but it is generally accepted that a cell-based ASIC or CBIC means a standard cell-based ASIC. Okay. So whatever IC that is a CBIC, कुठलाही आयसी जर तुम्ही घेतला तर त्याच्यामध्ये स्टँडर्ड सेल्स यूज केलेले असतात, त्यामुळे त्याला प्रत्येक आयसीला तुम्ही सीबिक असं म्हणू शकता किंवा स्टँडर्ड सेल बेस्ड असिक असं म्हणू शकता. द स्टँडर्ड सेल एरियाज दॅट ऑल्सो कॉल्ड flexible blocks in a CBIC are built of rows of a standard cells like a wall built of a brick. Okay. So whatever are the standard cells that are used in a CBIC, so that are built in a row. The standard cell area that may be fixed in combination with the microcontrollers or even microprocessor known as mega cells. Mega cells are also called mega functions, fully custom blocks, system level macros, or fixed blocks, cores, or functional standard blocks. Okay, so here besides standard cells, there may be mega cells that are present in a CBIC, which are microcontrollers or microprocessors. Okay, so that may be also present in a ASIC. So here you can see CBIC this structure. Okay, so here this is the row type standard cell area. Okay, here you can see a die with a single standard cell area, which is a flexible block. So here you can use this to connect to these blocks. So there are certain fixed blocks that are present. Okay, so these are not going to change their space, but these standard cells that you can change in such a way that you can customize this IC. The ASIC designer defines only the placement of the standard cells and the interconnect in CBIC. However, the standard cells can be placed wherever on the silicon. This means that all the mask layers of CBIC are customized and are unique to particular customer. The advantage of CBIC is that designers save time, money, and they also reduce risk by using a pre-designed or pre-tested as well as pre-characterized standard cell library. So here, as a designer is using pre-designed cells, so he need not to check for whether this his design is correct or not, whether he need to test that circuitry or not. So he can directly go with that cell. So that is the advantage, as it is going to save time as well as money or requirement for the designing purpose. In addition, each standard cell can be optimized individually. So that is also one of the advantage of this CBIC. During the design of the cell library, each and every transistor in every standard cell can be chosen to maximize speed or minimize area. The disadvantage are the time or expense of design or buying the standard cell library and the time needed to fabricate all layer of ASICs for each new design. Okay. Only disadvantage is that if we are using certain standard cell library, we need to purchase that library. Okay, because it is owned by certain manufacturer, so we need to uh, buy that. So, or we need to design already designed cell library we need to select, and then we need a certain time to fabricate all the layers of that ASIC. So that is only the disadvantage of this type of ASIC. Now, another type of ASIC, that is a semi-custom ASIC, that is a gate array based ASIC. Now, in a gate array or gate array based ASIC, the transistors are predefined on the silicon chip. So, the predefined pattern of these transistors on a gate array is the base array, and the smallest element that is replicated to make the base array is the base cell. Only the few layers of metal which define the interconnect between transistors are defined by the designer using custom marks. So to distinguish this type of gate array from the other types of gate array, it is often called as a masked gate array. So here, whenever we are going for the gate array based ASICs, we just need to define how all the transistors that need to be interconnected. Okay, so designer need to customize marks for that purpose only. Otherwise, all the transistors that are available on the wafer, silicon wafer, just interconnection between these transistor is the task of a designer. The designer chooses from a gate array library of pre-designed and pre-customized, pre-characterized logic cells. The logic cells in a gate array library are often called macros. The reason for this is that base cell layout in the same for each logic cell, and only the interconnect is customized, which is similar to software macro. Okay. So here these are the different types of the ASICs. Okay. Now as we have already discussed about PLDs and FPGAs, so here no need to discuss about this. So this is about the ASIC, that means it is a application specific IC. So in your examination again there will be question to write a short note on ASIC. So that type of question that will be there. So you need to write what is mean by ASICs, then what is the different types of ASICs, so that you need to specify. So that question may be nearly about 4 to 6 marks. So that is the about ASICs. So now let us move further and let us discuss about system on chip. Okay. So now as we know that whatever was the first generation of chip, that was using a very few transistors. Okay. So with a very few transistors, these ICs were evolved, and then nowadays there are lot of transistors on a chip. Okay, a very small size chip. There are hundreds, or not hundreds, but thousands or lakhs of transistors that are available, and this technology has enabled a new level of system integration into single chip. Okay, so because we have lot of transistor in a single chip, so we can design any circuitry in a single chip, and that is why we can see nowadays appliances, okay, like mobile phones, then portable computers, or any internet appliances that are built into a single chip. The demand for more powerful products and the huge capacity of today's silicon technology has moved system on chip design from leading edge to mainstream design practice. Okay. So nowadays, system on chip is a mainstream design practice. Now, System on chip technology that will put a maximum amount of technology into smallest possible space. Now you must have seen, okay, your earlier mobile phone, okay, म्हणजे तुम्ही जर आधीचे मोबाईल फोन बघितला असेल नोकियाचे वगैरे आय थिंक 3300 वगैरे असे काहीतरी मॉडेल्स होते, हे जर तुम्ही पाहिले असतील तर त्याचे साईज बघा तुम्ही, तिथे किती वेट पण त्याचं बघा आणि त्याचे साईज बघा, दॅट वेअर व्हेरी ऑफ बिग साईज, ओके, आणि त्याचे अँटिनाज वगैरे पण ते खूप मोठे होते, ओके. पण जर तुम्ही आता तुम्ही जे यूज करता ते मोबाईल्स बघितले तर त्याच्यामध्ये एवढे सारे ऍप्लिकेशन तुम्हाला एका मोबाईल फोन मध्ये मिळतात. म्हणजे तुमचा मोबाईल, मी आधी पण हे बोलले होते, कारण दिस इज द व्हेरी गुड एक्झाम्पल. आता जे तुम्ही VLSI टेक्नॉलॉजी शिकता त्याचं हे खूप गुड चांगलं एक्झाम्पल आहे की तुमचा मोबाईल फोन तर तुमच्या प्रत्येकाकडे आहे. तो मोबाईल जर तुम्ही बघितला तर तो तुम्ही इंटरनेट ब्राउझिंग साठी वापरू शकता, तुम्ही मेसेजिंग साठी वापरू शकता, तुम्ही कॉलिंग साठी वापरता, तुम्ही म्युझिक ऐकण्यासाठी वापरता, तुम्ही व्हिडिओ बघण्यासाठी वापरता, आणखी कुठलं ऍप्लिकेशन राहिलं, तुम्ही इमेज प्रोसेसिंग साठी वापरता. म्हणजे तुमच्याकडे मे बी बऱ्याच जणांकडे इतके सारे फोटोशॉपचे ऍप्स असतील, ओके. कित्येक गोष्टींसाठी तुम्ही तुमचा मोबाईल वापरता, ओके. सो दॅट मीन्स वॉट एव्हर इज द साईज ऑफ मोबाईल, ओके, दॅट इज नियरली सेम, पण त्याच्यामध्ये तुम्ही बऱ्याचशा गोष्टी बिल्ड केल्यात, ओके. आता डिझायनर्सनी बऱ्याचशा गोष्टी त्याच्यामध्ये बिल्ड केल्यात आणि त्यामुळे maximum amount of technology that is available on a very small space, and that is the advantage of system on chip technology, okay. So every system, whatever is the system that is available on a single chip, that is called as a system on chip, okay. So if we look for the paradigm shift in a SoC design, okay. Now in earlier days there was a system on a board, okay. That means that we have a PCB board and on that all the system were present. So it was having CPUs, then all FPGAs, all the components, that means whatever are the resistors and all that required, other ICs that required, then voltage supply regulators, here you can see that is also present on a single board, okay. But now with the technology changing, okay, so advancement in that, in the technology, we have now whole system on a single chip, okay. So here, so that means with in a very small size you can have a complete system, okay, in a single chip, and that is the system on chip technology, okay. So system on chip design, so that is if we define this system on chip, that is a complex IC that integrates the major functional elements of a complete end product into single chip. So as I said, it is a single IC which has all the functional elements in a single product. General SoC organization is like, it has a hardware which has at least one programmable processor, then it has memory element, it has accelerating function units implemented in the hardware, then it interfaces to the peripheral devices, it can interface to the real world, that means analog as well as MEMS component, okay? And then it has real-time OS software, then device drivers, okay. So all these is available in a single chip and which we call as a system on chip, okay. तुमचे जे काही फंक्शन्स आहेत ते एकाच मध्ये होणार आहेत. तुम्ही कुठलंही पेरिफेरल डिव्हाइस यू कॅन interface with that system on chip, as well as you can interact with a real world with the analog components or certain MEMS components. So if we look for the system viewpoint, then it is a collection of all kinds of components or subsystems that are appropriately interconnected to perform the specified functions for end users. So an SOC design is a product creation process, so which starts at identifying the end user needs, and then it ends at delivering a product with enough functional satisfaction to overcome the payment from the end user. Okay, so here whenever you are going for the associate design, what is the starting point? That what user needs. So depending on the user need, all the things are built on a single chip. म्हणजे मला काय पाहिजे हे जर मला माहिती आहे तर मी डिझायनर त्याच्याप्रमाणे डिझाईन करेल. ओके, सो व्हॉट आय वॉन्ट सर्टन memory element there. So whatever I am doing, that should be saved. So memory element is required. Then I want to process certain signals. So for that processor that is required. And then uh, another applications depending on my requirements, so that I need. So identifying all these needs and then starting design and then completing the design process and delivering it to the user. So that is the process for the SOC design. So there is a migration as from ASICs to SOCs now. It is ASICs are logic chips that are designed by end customers, okay, to perform the specific function for desired application. So that we have already seen. And these ASIC vendors supplies library for each technology they provide. In most cases, this library contains predefined and verified logic circuits. So as we have earlier seen that there are different types of ASIC technology, that is a full custom ASICs and then semi-custom ASICs. In that, standard cell-based ASICs and gate array-based ASICs. Okay, so these are the different types. So where the vendors of ASICs that are providing these standard cells and that, and then ASICs are designed as per the end customer's requirement. But in a SOC, what? Sorry. These ASIC technology that is evolved from a single set of philosophy to an embedded course-based system on chip concept. SOC, that is an IC which is designed by stitching together multiple standalone designs to provide full functionality for an application. Okay, so whatever was the ASICs that was already designed, that are connected together in such a way that, or that in other words here we have said that it is a stitching together in such a way that it gives us a single IC. An SOC composed of pre-designed models of complex function known as cores that serve a variety of applications. So there are certain cores that are present in ASICs, okay, that are pre-designed models. That means it may be certain logic block, okay, so which is already designed, so that is present on a SOC. The scenario for SOC design, it is characterized by three forms. One is the ASIC vendor design. That is, this refers to the design in which all the components in the chip are designed as well as fabricated by an ASIC vendor, or it is characterized by integrated design, which refers to a design by an ASIC vendor in which all components are not designed by that vendor, so which it implies that use of cores obtained from some other source such as core or IP vendor or any other foundry. Or it may be a desktop design, which refers to a design by fabless company that uses cores, which for the most part have been obtained from the other source such as IP companies, EDA companies, design services companies, or a foundry. Now, if we look at the benefits of using SOC, so it is reduced in size, reduced overall system cost, low power consumption, and increased performance. Okay. So as we can say that associates, that is we are combining a six. Okay, so in whatever is the our requirement, depending on that we are manufacturing these associates in a single chip, so it will reduce size. So overall system cost that will also get reduced because it is manufactured on a single chip. Then it is has low power consumption as well as increased performance is one of the benefit of SoC. And then these are certain platforms that are using ASICs. So if we compare SoC with ASICs, then uh, SoC is just not a large ASIC, but it is an architectural approach which is involving significant design risk, addresses the cost and time to market problems. So very low cost will be required for this manufacturing, and that is why uh, they are far better than ASIC. Okay. SOC methodology is an incremental step over ASIC technology because though both are customer design ICs, but still as SOCs are having all the components in a single chip, so it is a better than that of ASIC. SOC design is significantly more complex. Okay, so that is the disadvantage because of SOCs, because as we are having a large number of components in a single chip or their cores on a single chip, so design is complex. It needs cross domain optimization, then IP reuse and platform based design increase productivity, but that is not enough. Even with extensive IP reuse, many of the ASICs design problems remain, plus many more. So these are the different problems related with the SoCs. Okay, so you can see here uh, SoC here. Okay, so there is a very high level of integration as well as very high performance circuits and tools, then common architectural blocks that are also used, and then shorter designs that are used. And here because of this, here we require a shortened design cycle, and then it also productivity that is like. So typical applications of SOCs, that are an SOC that can be used in a any design system which is application specific. So like a microprocessor, then media processor, GPS controller, cellular phones, GSM phones, smart pages, ASICs, PC on a chip. So all these are the applications of the SoC. So that means in any consumer devices or in a networking or in a communications and other segments of electronics industries, SoCs are used. Okay, so these are the applications of this SoC. So here again, there may be a question on your examination on this to write a short note on SoC, that is a system on chip. So that type of question that will be there in your examination. So here almost we have completed all the points in your sixth unit, that is a architecture of commercial devices. Okay. So if you have any doubt, you can ask. Otherwise, from the next session, we are going to start with a new unit. Okay. So any doubt about this? It was just a theoretical part regarding ASICs and SoC. So any doubt? Vaishnavi,
Yes, ma'am.
any doubt?
No, ma'am.
So let us stop here. We will continue in the next session. Okay. So you may leave